Hello everyone, it's Mike Levin. Tuesday, February 10th, 2015. Out walking the dog. And today will be my first day back at the Flying Point Digital office after a week away coding. And to see what was up, you can go visit github.com/miclevin/pipulate, or really just my profile page at miclevin. M-I-K-L-E-V-I-N, and you'll see through probably, I don't know, April or May of last year, I started to become a little bit active on GitHub, and I've got some light green and occasionally a medium green here and there, and then for the past week I've been solid dark green. I'm up to, I don't know, about 900 contributions, which doesn't really mean anything because it's all based on the amount that you commit and I guess push, which I tend to do a lot because I like to get the code into more than one place as soon as I can, as soon as I'm happy with it. And so I made as much progress as that color coding would indicate, and I did probably some of the stuff I'm most happy with coding wise in my life. And I guess I had two prior projects where I got into this kind of zone. One of them was a generalized system at Scala Digital Signage from, I don't know, 15 years ago or so. I guess that's how long ago it dates from, and it's still in use today, if you can imagine that. It was so well keyed to their problems that it just never was worth replacing. And the second project was, I guess, 360i Tiger, when I worked for that digital marketing firm that did the Super Bowl tweet a few years back for Oreo, you can still dunk in the dark. I was on their SEO team as a director for many years, and to keep myself sharp and to re-platform myself onto Linux, Python, Vim, and Git, I took up that project, and I briefly got into the zone on that. And then I had a kid, and this, I guess, is the third time where I'm really recapturing that feeling of being transported somewhere else, where the nuanced problems of what you're working on are actually the most interesting thing, the thing you would actually most want to be doing at that point in life. And you know, I love my kid dearly, and pretty much the biggest problem with my approach right now is not being able to take all the time in the evenings I'd like to just play with her. But it's a phase thing. This is the kind of thing where you put a lot of effort in over a short period of time, you build something, and then you can ride that momentum for many years in life, and you'll be in a much better position than if you didn't do that work. So I'm actually quite happy, and I get to explain to Addie what I'm doing, and she sees me coding, and she's like, "Oh, Daddy, are you coding?" And I'm like, "Yes." And she's like, "Well, why can't you play with Legos with me?" I'm like, "Well, what I'm doing is a lot like Legos, but just with code, and I'll help teach you to do it someday." And she's like, "Oh, is it something I can do?" I'm like, "Yes, it's what I do when I go to the office, and you use it for all kinds of things." And I got to explaining how robots, if she joins those robot battle teams, they're not just controlled by remote control with people on little, you know, video game controllers. There's programming that goes behind them, and you can make them do their things without even having a human there on the controllers. And that kind of programming is in everything. And hopefully I'll be able to kind of share that experience with her as it's more meaningful to her. And we'll start with the dash and dot robots, which we have, which is has a sort of visual drag and drop programming. Symbolic programming is fine. Even text-based programming is symbolic, because, you know, the characters that you type out, the strings that you make are symbols. It's just less rigid, shall we say, easier to make mistakes. It requires a larger skill set to construct those symbols correctly on the screen than to just pick up something from point A and drag it over to point B, and to draw lines and pipes and stuff between things. So, what do I want to say about the project? It's those tiny, nuanced little things that'll get you. Not in a bad way. I'm loving the work, but I'm at the point where I have to program very defensively in the way that I guess Joel Spolsky advocates. You know, in one of his books, I guess his first book, Joel on Software, he talks about an approach to programming where, you know, you'll never have to like debug because you program defensively from the start, capturing every every unusual condition, testing for things, and it's just programming defensively. And I don't really believe you can keep the bugs out, especially in this API world of ours with latency issues and availability issues. But I am going to give it my best try, and Python is certainly the best language I've ever worked with for that. I still am hurting a little bit from VB-Script, Visual Basic Scripting Edition, on our go-to hell is what they call it. And you know, I lived with that for a very long time, and it's basically, if an error happened, throw your code to some other location. But it didn't have a lot of elegance to it. And in Python, you have try, except, and then you also have else. So if you try something and it works, and you want something else to happen as a result of the thing you just tried, but you don't want that next thing to pollute your error messages, you put it in the else statement. So try, except, else. The thing under the else executes if try succeeds, but any potential error messages that was generated from a failed try is not corrupted, or a successful try. It's not corrupted by being in the same block as the thing that generated the error. And then there's also a finally, which is a block where you can put things to, I don't know, like clean up afterwards, regardless of whether your try condition succeeded or failed. So it's an awful lot of power in handling all these conditions. And when something might not work and you know it might not work, things like objects not existing that you think you have at that time, you just put it in a try, and otherwise critical errors that would normally stop the program flow, indexes out of range, you know, all kinds of things, will allow the program to continue running. And in order to do it gracefully, you just have to tell it what to do if that object doesn't exist. But you don't even have to specify that it doesn't exist. You just can put it all in one grouped except block. But it gets better than that, because the errors give you all kinds of names that you can do variable behavior on. So you can detect if it's an HTTP failure, a failure in assignments to your assignments or arguments to your functions, and you can like have it chained up like an if, else, essentially, capturing every different thing that could go wrong and handling it differently for the different situations. So you can program defensively really well in Python. And what else? Oh, debugging. I'm actually opening 3 channels of communication to the user through the browser. That is, if you don't include the initial page load. But I basically have 3 locations on the page where I'm streaming messages to the user. So I can stream one type of message to one area on the user interface, another type to a different place, and that's just to the user. Now for debugging, I can of course write to a file, which I haven't been doing on this project, but I'm writing to the console that the web server is running from. So on every page load, I get to watch the console, and it's like as if you had a screen where instead of trying to look at log files or analytics, you can just see what the web server is saying as page requests are made. And it's just really a pleasure, a view of things that I've always wanted but have never really had, and it's really easy. And you ask, well, how do you get it into that running invisibly mode that like Apache and Nginx work as? Well, you can do that. In fact, you can set up your servers so that on startup, it runs your Python program as what they call a daemon, which is invisible and in the background with the capacity to relaunch on failure and stuff. But if it does fail, you can actually have a scheduled job to relaunch it so that if something critical goes wrong, you can have it being checked every minute to relaunch it. So when you want to do work on that server, if you're using it as a production and a debugging server, which I'm currently now doing even though nothing's really in production, you just stop the daemon with a command /etc/init.d /pipulate space stop, and it'll stop it, and then that stops it from running in its sort of invisible mode, and then you can run it again by doing Python space pipulate.py, and now you can see all the interaction with the user in the web browser from the server side by watching the console. And you can write out all your debugging messages there, which is just really a pleasure to watch. If you make very detailed, verbose debugging messages, you can just follow the entire program execution flow. And I'm even starting to format that so I can visually identify programming blocks that are being entered and exited by watching output on the terminal window. So anyway, this has been a particularly rambling message, but I wanted to get across how interesting the work is getting, and how how much of a pleasure it is to work in Linux, Python, Vim, and Git, and how, because this is my second major project in that environment, I'm making a lot of decisions much better this second time than I made the first time around. And hopefully it'll become a project that a lot of people can hop on the bandwagon with on GitHub, and start to either have a similar experience or get introduced to this platform that I call the Short Stack for the first time. So thanks for joining me. I'll make some demos of it coming up so you can see what this Pipulate thing is that I've been talking about for so long. Don't forget to subscribe and refer someone to the video who needs to see it, and talk to you soon.